Hello everyone. So in this video we are going to talk about Apache Spark. So what is exactly Apache Spark? So Apache Spark is an open source distributed computing system that is designed for fast processing of large scale data. Initially developed by the University of California, Berkeley. Spark was built to address the limitations of Hadoop's MapReduce by offering faster data processing through in-memory computation. Spark provides APIs for multiple programming languages like Java, Scala, Python, and R, making it highly versatile and accessible for developers. It is used for a wide range of data processing tasks such as batch processing, stream processing, machine learning, and graph processing. So here are various key features of Apache Spark. So the first is speed. Spark performs data processing tasks much faster than traditional MapReduce because it stores intermediate data in memory (RAM) rather than writing it to disk, reducing the time needed for input-output operations. Spark's ability to handle both batch and real-time data processing also contributes to its speed, making it suitable for time-sensitive applications. So the second is ease of use. Sparks come with high-level API that is easy to use even for those who are not experts in distributed systems. The availability of language built bindings in Java, Scala, Python, and R allows developers to write code in the language they are most comfortable with. It also provides powerful libraries for machine learning, graph processing, and SQL queries. The third is versatility. Apache Spark can process a variety of data types, including structured, semi-structured, and unstructured data. It supports real-time streaming via Spark Streaming, machine learning via MLI, and graph processing via GraphX, making it versatile for a range of use cases. Spark can run on top of Hadoop using its distributed storage, HDFS, or operate independently with other storage systems. And fourth is fault tolerance. Spark ensures that data processing tasks are resilient and can recover from failure. It uses a mechanism called as Resilient Distributed Data Sets (RDDS), which track the lineage of transformations, allowing it to recompute the lost data in the event of a failure. This fault tolerance ensures that the system can recover and continue processing without data loss.
I'll be talking about Apache Spark and its key components. The first is Apache Core. This is the heart of Apache Spark. It provides the foundation for distributed data processing using resilient distributed data sets, which are also called as RDDs. Spark SQL. This allows user to run SQL queries on data stored in Spark. It integrates well with structured data and makes it easier for users familiar with SQL. The third is Spark Streaming. This component helps processing real-time data streams, making it greater for live data analysis. MLlib, Apache Spark's machine learning library. It provides tool for building machine learning models efficiently. And the last is GraphX. This is Spark's graph computation engine. It helps analyze and manipulate graphs, making it useful for applications like social network analysis. And now coming to the use cases of Apache Spark. The first is big data analytics. Spark is great at processing large data sets quickly, making it perfect for businesses that need deep insights. Real-time streaming. Companies use Spark streaming to analyze live data. For example, it can be used for Twitter sentiment analysis to understand trends in real time. Machine learning. With MLlib, businesses can easily build fraud detection system, recommendation engines, and predictive models. ELT process. Spark is widely used for extract, transform, and load tasks, helping organizations to pull data from multiple sources.
Apache Spark is designed to handle big data processing in a distributed and parallel way, which makes it both scalable and fast. Its architecture consists of driver program, cluster manager, executor and task, RDDs, and DH execution model. First of all, let's see the driver program. The driver program is the main control unit of Spark application. Here's what driver program does. It runs the main application code that the developer, writes. It creates Spark session, which is the entry point of the interacting with Spark. The driver takes you, the driver takes your transformations and actions such as filtering, or aggregating data and converts them into DAG, that is directed and acyclic graph. Next, let's look upon cluster manager. The cluster manager is responsible for resource allocation and management. Here's what cluster manager supports. It is standalone, it is Spark's built-in cluster manager is great for smaller setups. Second is Yarn, common in head-up environments. Third is Mesos, a more general purpose cluster manager. And fourth is Kubernetes, ideal for containerized deployments. Third, let's look upon executors and tasks. Executors are the work nodes responsible for executing tasks. Each executor runs tasks in parallel and stores data for RDDs, that is, resilient distributed data sets in memory or disk. Let's look upon both, that is RDD and DAG. So RDD, that is that we saw as resilient distributed data sets, are core abstraction in Spark for handling data. The DAG, that is direct acyclic graph execution model, represents the sequence of transforming and acting applied to RDDs, ensuring fault tolerance and optimized execution. So this is the Apache Spark architecture.